Hello everyone, Mr. Bowman here. I am going to be your instructor for Chapter 3, and I would like to start out with giving you a short description of what Chapter 3 covers. Chapter 3 is strictly about the relationship between two quantitative variables, similar to what we looked at between two categorical variables with two-way tables. In this chapter, we're going to cover how to graph that relationship, how to describe that relationship both in words and with numbers, how to find a linear relationship between two quantitative variables, how to and not to make prediction using those linear relationships, and how to measure the strength of those linear relationships. On the page you see in front of you are the learning targets for the chapter, and I've done my best to highlight which activity those are covered in. I will tell you that there is going to be some overlap in some cases. For example, interpreting the correlation is going to come up in this first activity 3.1a as well. In activity 3.1a, we want to cover these first three learning targets and a bit of the fourth one there. So take a moment and read those before we get started. As you saw in the previous two chapters, you do get a formula sheet on the AP exam, and Ms. Harding and I will be allowing you to use it on all your quizzes and tests. We are going to delve into that a little bit deeper in this chapter, and we are going to look at the following formulas, these right here and right there. Along with this, let's see, I guess that's it for now. So let's get started with activity 3.1a. The first thing that gets covered in activity 3.1a is the idea of an explanatory and a response variable. And I want to be clear here that this is not the same idea as in an experiment. In an experiment, we are trying to establish a cause and effect relationship, the explanatory variable being the cause for what happens with the response variable. In this situation where we're looking at relationships between two quantitative variables, even though we call one an explanatory variable and one a response variable, we are not interested in causal relationships between the two. The explanatory variable takes the values on the x-axis, the response variable takes the values on the y-axis, and so before we go any further, I'd like you to take a few moments and read these examples and see if you can figure out which variable you would classify as the explanatory variable, which one you would classify as the response variable, and whether or not you think it's reasonable that there's a cause-effect relationship there. In the first example, hopefully you said writing thank you is the explanatory variable and tipping percent is the response variable. In the second example, hopefully you were a little bit confused by that and you weren't really sure which one would be the explanatory and which one would be the response variable there. Well, I would agree with you on that. In that case, well, actually, in any case, we can decide what we want the explanatory variable and what we would want the response variable to be. Unlike in the first example, we would typically think of writing thank you as preceding the tipping percentage, but we don't have to do it that way. And in the third example, you would probably assume that there is a cause and effect relationship there, that working more hours causes more pay, and thus you would consider hours worked as the explanatory variable and pay as the response variable. However, for the purposes of this chapter, if we're not trying to establish a cause and effect relationship, we can always turn that around and say things like the pay is the explanatory variable and we will use that to predict the number of hours worked. The next thing we want to do is we want to talk about how to graph the relationships between two quantitative variables. And you are all very familiar with this idea of plotting points on an XY or Cartesian coordinate system. And that's what we're going to do for what are called scatter plots. we are going to pick one of the variables to be the x-coordinate and one of the variables to be the y-coordinate. So in this example, what we have here is we have the categorical variable model of car, and each model should have associated with it a city miles per gallon and a weight. Now there is one exception to that. The Audi TT right here does not have a city miles per gallon. I'm not sure why, but when we go to plot those points, we're going to have to leave the Audi TT out because of that. So what I'd like you to do now is I would like you to make a scatter plot. And as I said before, the scatter plot is going to be a plot of the points associated with x values as the explanatory variable and y values as the response variable for each of the cars. And so take some time, scale and label both of the axes appropriately, and title the graph, and then plot each of the points for each of the cars. When you've finished, you should have a scatter plot that looks something like this. There would be a title up at the top, there would be scales and labels on both axes, and then your points are plotted. Now you might notice that I do not have a label on the x-axis, and that is simply because it got pushed off to the next page. So that is the weight of the cars in pounds. The value in a scatter plot is similar to the value in a segmented bar graph. The segmented bar graph allows us to see associations between two categorical variables, whereas the scatter plot allows us to see associations between two quantitative variables. So now I think that we can start to see that there appears to be what we call a negative association between the weight of the car in pounds and the city miles per gallon. It also looks like the association is linear. So the next thing we want to talk about is interpreting the scatter plots or describing the associations between the two quantitative variables. So we should do things like describe the overall pattern. Is it linear or curved? What's the direction of the association? Is y increasing as x is increasing, which is called increasing, or is y decreasing as x is increasing, which is called decreasing? The strength of the association, how strong or clear is that pattern, weak, moderate, or strong, and whether or not you notice any unusual features like outliers or clusters. And keeping in mind that we always do this in context. So why don't you take a moment, take a look at this list of things that you should do when you're describing an association between two quantitative variables. And in part E, write a short description of the association between the weight of the car and the city miles per gallon. So hopefully you had a description that went something like this. The association between weight and city miles per gallon appears fairly linear, negative in direction, and moderate in strength. There does not appear to be any outliers, but clusters may exist. And we'll go back and we'll take a look at that graph so you can see what I'm talking about here. And the clusters that I'm referring to would be those, and possibly those, and those right there. One of the things that students often struggle with early on when we're looking at scatter plots and associations between two quantitative variables is how to describe the strength of the association. So we're going to look at some examples of some scatter plots, and you're going to rank them from weakest to strongest. So here's what we have. We have the following scatter plots. So you have scatter plot A and B and C and D and E and F and G and H and I. And what I would like you to do is pause the video and take a moment and rank them in order from most strongly negative association to most strongly positive. So, for example, B has a very strong positive association. D has a medium strength negative association. So take these 9 scatter plots and rank them from most strongly negative to most strongly positive. And I think the easiest way to do that is clearly start out on the left hand and the right hand side of this, and then we'll come back in a moment and see how you did. Alright, so here are the rankings from most strongly negative association to most strongly positive association. Give yourself a pat on the back if you got those correct. There are some of them that you might have 2 letters rearranged, but if you've got more than that out of order, for example, if you had A and E switched, for example, you should probably go back and take another look at that. I would like to take a minute and give you some techniques for helping you kind of figure out the strength and the direction of the association, particularly with the ones that are not quite as strong. So one of the techniques that you can use to help you determine the strength and the direction of the association is to draw the smallest rectangle that you can around the points and take a look at the direction of the longer axis of the rectangle, and that would establish the direction of the association. If that longer axis has a negative slope, then it would be a negative association. If it has a positive slope, then it has a positive association. As far as the strength is concerned, take a look at the ratio of what I'm going to call the length along the longer axis compared to the width perpendicular to the longer axis. And the larger that ratio is, the stronger that association is. So that is one way to help you determine the strength and the direction of the association. In the future, we're going to have a numerical measure of that, which can be done with a calculator. Sometimes drawing these rectangles, it's a little hard to determine the direction of the rectangle, and so give it some time, practice a little bit, and see what you can do with that. We are going to finish up this activity by taking a look at a couple of interesting associations between 2 quantitative variables and take a look at some things you can do with scatter plots that you might not have otherwise thought of. In this scatter plot, we have a plot of wife's age at marriage versus husband's age at marriage. And we also have the line y is equal to x drawn in there. So one of the questions that comes up very often is, what's the significance of the point lying above the line, below the line, or on the line? Well, as you know, if a point is on the line y is equal to x, the x coordinate and the y coordinate are the same. So what we could say about this particular couple here is that their ages when they got married were approximately equal to each other. Then you could ask the question about a point below the line. So this point below the line, we can see that the wife was about 32 years old when she got married, and the husband was less than 25 years old. So below the line, we could say that y is less than x, or we can say in this case that the husband was younger than the wife when they got married. Similarly, if we were to pick a point above the line y is equal to x, we could say that y is greater than x, or that the husband was older than the wife when they got married. The last example we want to take a look at is an example where we add to this relationship between 2 quantitative variables a categorical variable. And this is an example showing data on 24 different sandwiches from the fast food chain Arby's, and it's the serving size in ounces as the explanatory variable and the number of calories as the response variable, and we can see that there's a pretty strong positive linear association between these 2 variables. Well, if we wanted to, we could throw a categorical variable in there, and in this case we're going to do that, and it is the type of meat on the sandwich. And so if we take a look at that, we now have different symbols showing the different types of meat. So yellow X's are roast beef, blue triangles are turkey, green triangles are ham, the one fish sandwich in blue square, and the circles are chicken. And that allows us to do things like determine possibly if there are different types of associations based on those categorical variables. To finish up here with an example about manatees and boat registrations and the number of manatees that were killed by boats in various years, I would like you to make a scatter plot of the number of boat registrations versus the number of manatees killed based on the year. So each year will have a number of boat registrations associated with it and the number of manatees that were killed by boats. And I would like you to think about what you think should be the explanatory variable, what you think should be the response variable. Make a scatter plot of those two, and then describe the association between those two. Alright, so I used some computer software to make my scatter plot, and you can see that there appears to be a fairly strong positive linear association between the number of boat registrations and the number of manatees killed. I provided a title, I provided labels on both axes, and my description was the following. The association between the number of boat registrations and manatee deaths is strong, positive, and linear. So that's it for this first activity. If you have any questions, make sure that you ask your teacher about them in class.